So this is video number 6. Video number 6 is going to cover the terrain. So I'll start off with the terrain object itself. So given a basically given a height map file and basically a string for the texture that I'll apply on the object later on, a size, a repeated U and a repeated V, I will create a height map. Very first thing I do is I save this size and the scale because it's very helpful to just always maintain what's the scale of my terrain. So I save that first. I get all my I read the TGA itself, and I do a few extra things. This is where it's important because it goes into right here. I think it's somewhere you mentioned you don't want us to save our vertex, our p-verts, and our p-triangle list. So just to show this off, I allocate this new space here, and at the end, p-verts and p-triangle list, they're completely deleted. They're thrown out. But going through this, I calculate my X position. My Y position is based on the on any one of the RGB colors, since it's just going to be a black and white image anyways. I also have this little effect, so that way I'm always I think that was supposed to be somewhere else, but I always try to maintain centered in the world. My Z position and my U and my V are all calculated here. A lot of this math is just copied and pasted from our DX project back in the graphics class. But the next thing that I do that is important and is different is I save in this cells variable. I create an array of terrain data. And terrain data holds min and max points. So it holds a min vector and a max vector for my AABB later on. So I basically create my triangles. Right here, you can see I get my first 2 points, and I have to check my min and my max here. So I have a temporary min and max equal to whatever the min and the max are of these two. Then I do it against these two, and then I do it against these two. This top corner is just an arbitrary value, but at the very end, I'll end up with a min and a max point given all my test. So first two, second two, third two. And then I store those values in the min and max points given the place. The place is the cell. And my min and max points are there. And after that, we move on. So we go into our place and we just continue on. At the very end, we create our model for our terrain, and we also create our graphics object from that. These two things are managed by the terrain itself. The terrain holds its own model and terrain, and we make sure we delete those when the terrain is deleted. What controls what holds on to the terrain, I'll go into the terrain manager after this. But we submit entry as a drawable and a collidable. You are right on this case. Yeah, we don't necessarily need to make it a collidable, but having it quickly be implementable with the system that we already had in place, I left it as a collidable. Our world is basically just our identity matrix. This is only updated once on scene entry, since the terrain doesn't move, everything moves around the terrain. And on scene exit, we deregister both of the things that we did before. On draw, we just render the terrain. The terrain is rendered before everything else because it's the ground. It has to come first. I had this for debugging so I could see all the basically all the cubes on, or all the AABBs, all the cells on the terrain. This is my helper function that I mentioned before that makes it really easy to basically get my cell number and my horizontal and vertical position of that cell. And this just makes doing all the calculation a little bit easier. And I did believe that the responsibility of doing those calculations rests in the terrain and not anything else. I also had this debug mode, so I could use this as a reference to make sure I am rendering things that I want. So I use this to basically just render a given area. This was eventually moved into the iterator to be a lot simpler, but I left it here just as a simple debug. So if the user just says, this is my min point, this is my max point, give me those cells, it will render all those cells. But again, that was just for debugging. Going on to the terrain manager, the terrain manager is a singleton. It gets initialized when the user provides their resources. So right here, they load a terrain. They basically give it the name, the username, the file, which will be in the terrain folder. They give it a texture to place on it, so it's text plane, the texture, and we give it a scale. If they don't provide a scale, it just defaults to 100, which is relatively small, but that is the default. Going into the terrain manager once again, let's go into here. I have debug out, which is a macro just to print out all these things. I'll go all the way to the top, and as you can see, we load our terrain right here. So right here, I'm going to assume these are right here. This is the call. So we load it. It's a success after we've loaded it. And at the very, very end, when we are going through and we terminate our scene, which will be here in our game engine right here. When we unload all our content, our terrain manager unloads all our terrains. When we do that, we just iterate through our map. We delete all the things in our map, and then we destroy our terrain manager. When pbumpy, which was the terrain that I mentioned, gets deleted, we also delete our data, which was right here, our game object and our model, since this terrain is responsible for that information. You are right on. You are also right that there is the better way of storing this information, since I'm storing 8 floats per cell, which is a ton of information. All I think I would relatively need is maybe a center point and a radius. So that's 4 vectors plus that's 4 floats plus an additional float, so 5, because I know how to calculate an AABB given a B-sphere, which I know is 5 floats, so that could minimize it by 3. And you did mention in class that there was another way. Going back, I should modify that, but that is something else. Let's see. A few floats for instant basic geometry. Going back to this, I can show that the only things that I store are my graphics object, my model, and I am responsible for these things, so I delete them. My cells, which I have, and I'll delete. I have my scale, which is used for calculation, my side, and my difference to the next position, which is basically the width of my cell. This information is used So I'm able to extract, I'm able to convert a vector when I get the one below and convert it into the math for a cell and give it back to the user. As I mentioned, they were destroyed. Methods, internal support. I've mentioned the things that I call. I have basic accessors for get scale, get the difference between positions, and everything else. Let's see, I've showed off my terrain manager and my collision with terrain. I've mentioned it in detail. I'll just do it very quickly. And I've mentioned through, I get my area given my min and max point. I use the helper function to get those 2 points. I iterate through them first horizontally, then vertically. And once I reach the end, I'm done. I try to early out as much as possible. Collision with terrain. Oh, I should show how the user initializes this. So the user scene, they set the terrain for the scene, and they also set collision terrains with, they set the collision given an X or an object, and then later on we can deregister the terrain collision, and we can also remove the terrain from the scene. Yes, I've shown multiple times, but I'll show it one more time. Let's see. Okay, so my character is over here. As you can see, I covered these 6 blocks right now. If I move a little bit forward, I'm only within the area of those blocks. If I move diagonally, once again, I do this. The max that I'll ever hit is I'll be in the area of these 9 blocks, so I only test what I need to. As I get closer, you can see right here that I've reached a point where I'm very close to starting a collision, but I have not fully interacted with these points. Once I move a little bit closer, my ABB marks the register collision that I am touching these blocks and I've collided. Granted, because this is scaled up so large and the terrain isn't the most high res, these blocks do occasionally not look like they are colliding, but I do think that is because of round-off errors and the way collisions occur. So here's not a collision, there is a collision, not is, not is, not is. So yeah, I'm only testing those cells for each cell. As I mentioned, I do my ABB first, and then I do my user-defined one. Let's see, show that the test is functionally even when I move off any of the 4 sides of the terrain. I think I've done that. I think that covers the terrain.